This video is being made to remind everybody about how to factor. As you've heard me say many times in class, factoring does not go away. So the sheet we're looking at here is the flow chart we used when we were factoring quadratics, right? In general, we want to look at these different categories as we factor and we move into our next module, chapter 9, which still works with rational functions. So we have these ratios of polynomials and we're going to need to be able to factor. So first and foremost, I always say, what's the top line on the factoring flow chart? Factor out any common monomial terms, right? That's important every single time, right? Then if we have two terms left, we decide if it's a difference of perfect squares. If it's three terms, we need to look at how to factor that quadratic, right? Three-term quadratic trinomial. If it's four terms, we're looking at factoring by grouping. Finally, we revisit factors at the end and make sure we don't have any further difference of perfect squares. So the rest of this video is me showing you some more examples of factoring, okay? So here, first thing I'm going to do, I'll start with this one here, number 1. First thing I'm going to do is see, are there any common monomial terms? No. There's nothing that's common in both of these terms that I can take out, that I can factor out. Second, I say, oh look, it's two terms. Are these, or is this a difference of perfect squares? Well, notice, what can I square to get 2 or 4r squared? Well, 2r, right? What can I square to get 9? All right, 3. Sorry, squared. So remember, a squared minus b squared is a plus b, a minus b. So what we're doing is we're identifying a, we're identifying b. So the answer is 2r minus 3, 2r plus 3. The second example right now doesn't look like a difference of perfect squares. But remember, we got to go back to the first thing to do every single time. Factor out common monomial terms. Well, these are both even, so I am going to factor out a 2. So if I factor a 2 out of 98, I'm left with 49x squared. 2 out of the 32 leaves me with 16. Well, now, looks like I might have a difference of perfect squares. What is squared to give me 49x squared? 7x. What is squared to give me 16? 4. So this is 7x minus 4, 7x plus 4. Don't forget this factor I took out earlier. So these are two examples of difference of perfect squares. Here we're doing some trinomials where a is 1. So I'm going to do the first one two different ways. Usually if a is 1, I say what numbers multiply to get 20 and add to get -9. All right. Well, I have to think of the factors of 20, 20 and 1, 10 and 2, 4 and 5. Oh, hey, isn't -4 times -5 equal to positive 20? And they add to -9. So I can simply say x minus 4, x minus 5. If you want to handle these using the second process where a isn't equal to 1, we can still do it here. We can say, okay, a times c is equal to 1 times 20, right? Equals 20. What factors of 20 add up to -9? Well, -4 and -5. Now, rewrite the trinomial by expanding the middle term. X squared minus 4x minus 5x plus 20. Now we can solve it by factoring by grouping, right? So x is common in this first part. What's left is x minus 4. All right, now I need the parentheses on the second part to be the same. I'm going to factor out a -5. I get x minus 4. These two come together as one of the factors. This is your second factor. Okay, we get the same answer either way. Okay, over here, I'm going to do it the simpler way. A equals 1. I know it's going to be two binomials, x and x. What numbers multiply to negative 12 and add to positive 3? All right, let's think. 12 and 1, 6 and 2, 4 and 3. Notice that this one does not seem to be factorable. There are no factors of negative 12, right? That would mean one of these factors would be negative in each set that add to negative 3. So this one is not factorable. Moving on. Here is where A does not equal 1. So we have to use the formula or the process where we multiply A times C. In this case, 5 times 6 is 30. What factors of a positive 30 add up to negative 17? Well, if you need to, write down different factors of 30. Well, it's going to be negative 15 times negative 2. So now I will rewrite this by expanding the middle term, and I will factor by grouping. What's common in the first part? A 5 and an x. That leaves me with x minus 3. Now I need the same parentheses here. What am I going to factor out to make that work? A negative 2, x minus 3. 5x minus 2 is one of my factors, x minus 3. Same process for this one. But in this case, I'm going to go back to the top of my flowchart. Is there a common monomial term I can factor out? Well, I believe there is. I think I can take a 4 out. That leaves me 3x squared minus x minus 10. I believe that's right. Now, A does not equal 1. So I'm going to say A times C, in this case, is 3 times negative 10, gives me negative 30. Are there factors of negative 30 that add up to the negative 1 right there? Well, I believe it's negative 6, positive 5. So I'm going to rewrite this, expanding the middle term, right? And factor by grouping. I can factor a 2x, whoops, not a 2x, a 3x out. And I get x minus 2. And then I can factor a 5 out at x minus 2. Right? 3x plus 5 is one of my factors, x minus 2. Okay? Finally, we're going to do a factor by grouping. First of all, I cannot factor out any common monomial terms. Okay. And then if I have 4 terms that I can't put together, right? None of them are like terms. None of them are like, right? I got to use factoring by grouping. So I look at the first set, and I notice that I can take an x squared out of both of those, and I'll have an x minus 3 left. All right, what can I take out of the second 2 terms that's common? That'll give me an x minus 3. I'm actually going to take out negative 16. When I take out negative 16, that gives me x minus 3. So notice x squared minus 16, x minus 3. Well, the last line in that flowchart says, revisit your binomials and see if you have any difference of perfect squares. Right here, I have a difference of perfect squares, right? So that factors into x minus 4, x plus 4. Then I still have the x minus 3. And this would be the factored form of that polynomial. All right? Take a look at these. Practice. Stop the video. Practice on your paper and see if you get the same answer. Okay? Thank you.